Okay. Hi, and welcome back. So this is the second video of our class today, March 23rd. So hopefully you have already watched the first video. So on every slide, I'm going to put up these, on every lecture, I'm going to put up this first slide that kind of guides us through what the lecture is going to consist of. So today you should watch video 1, which hopefully you already did, which is welcome to our new online class. And then you have to respond to the mini assessment number 1. Okay, the second video, that's this one here, is an overview of climate change and biodiversity, and that corresponds to slides 3 through 16 on the PowerPoint. Then you watch video 3, which is Can Wildlife Adapt to Climate Change? And that's an external video. And then you watch, you'll watch video 4, which is I'm going to tell you about a little bit of the effects of climate change here in the Adirondacks. And then you'll do your mini assessment number 2, which is questions on those videos 2 through 4. Okay, so let's dig into it. So overview of climate change. So hopefully at this point, everybody in class knows the basics of climate change. I'm going to do a quick review just to bring us up to speed. And when I say quick, I mean quick, because I hope that you already know these basics. So number 1, take a deep breath. This is what you just breathed in. 78% nitrogen, 20% oxygen, and then a teeny tiny little bit of argon, carbon dioxide, and other gases. What other gases? Various other gases, but they include the greenhouse gases. Now, the greenhouse gases are called that because they're the ones that are very good at reflecting heat that's coming off of the earth back down to the earth, so they heat it up. Now, those include carbon dioxide, carbon monoxide, nitrous oxide, methane, ozone, and sulfur dioxide. Now, you've probably hear the most about carbon dioxide, but some of these other ones are also quite powerful and are quite potent greenhouse gases. So carbon monoxide, we know that comes from car exhaust, right? What about methane? Methane comes from, I know my interest students know this, it comes from cow farts. Literally the methane that we're emitting into the environment is from our massive beef production, and when the cows fart, it contributes to global warming. So these are all the greenhouse gases, and our increased emittance of them into the environment is causing climate change. All right, how do we know that? How do we know that we're causing it? Let's look, let me walk over to this side. Let's look down here at the past. So these are past temperature fluctuations. And if you look down at that x-axis there, it says thousands of years ago. So this only goes to 400,000 years ago. So you can see that the temperature on Earth, that top graph, and the carbon dioxide on Earth, the bottom graph, has fluctuated a lot. It's fluctuated extensively over time. And the time period that we're in now, so go look at 0, is not out of the realm of what Earth has been like before. So we are not living in unprecedented climate conditions. But, all right, got to walk over to this side. But here's the thing. Conditions never change this rapidly on Earth without huge, dramatic ecological consequences. So a lot of those peaks in increase in temperature and carbon dioxide that you see correspond with massive peaks in extinction, mass extinction events. So essentially, yes, these conditions have existed before on the planet, but Homo sapiens has never existed in these conditions. And Homo sapiens, we do not want to exist in these conditions. It will not be pretty. Okay, so I hope this helps you to understand why climate change, even if we've seen these temperatures in the past, is not something that we want to have to try and maintain our human society through. Okay, how do we know it's people's fault? How do we know it's anthropogenic or caused by people? Well, if we have some pretty compelling data showing that since the Industrial Revolution, which is when we started inventing a lot of machines, motors that use fossil fuels to run, atmospheric carbon dioxide has been increasing, not exponentially, but steadily and linearly. So these measurements here were some of the earliest ones that they started taking actually at the top of Mauna Loa, the volcano in Hawaii. Not a bad place to have a climate station and hang out and take measurements. So this data has been collected there since the mid-50s, and you can see that it shows a clear trend of increase in atmospheric carbon dioxide. The black line is the measurements from Mauna Loa, and then the red line is global measurements. So since the Industrial Revolution, this has dramatically increased. And just a shout out here to coronavirus. So what we're seeing now in the world is unprecedented in the last 200 years. In general, ever since the Industrial Revolution, humans have emitted more greenhouse gases into the atmosphere every year until this year. This map shows the amount, this actually isn't carbon dioxide, I couldn't find that, it's nitrous oxide, but that's another greenhouse gas. So this is nitrous oxide over near northern China where Beijing is. During the month of January this year, you can see that on the left is all of the mean atmospheric nitrous oxide, and look at it in February. So after the coronavirus hit and China shut down. So what we're experiencing now is terrible for human society, but fascinating in terms of our ability to reduce greenhouse gas emissions. We can do it, apparently. We don't want to, but we can. Okay, so moving on from coronavirus. So who summarizes all of this data together and tells us what they think is going to happen? It's this organization, the Intergovernmental Panel on Climate Change. So this is their report from 2014, and basically where they get this data is they collect scientific data from all over the world, from all the different scientists who are working on climate science, and they summarize it and they use it to model potential scenarios. So what do they think is going to happen in the future under different climate change scenarios? So some of their main predictions, and I'll walk over here, are that, well, this isn't a prediction, this is a certainty. Well, it's a 95% certainty that human activities are responsible for global warming. We also know that carbon dioxide is at an unprecedented level not seen in the past 800,000 years. So in case you don't remember, Homo sapiens evolved about 200,000 years ago. So we've never lived in an atmosphere with this much carbon dioxide. Sea level is continuing to rise, and that's because the ice sheets are melting and glaciers worldwide are also melting. So we're transforming those holds of fresh water into sea level. Okay, so what are some of the observed impacts of all this activity? Sea level rise, which we just talked about. Severe storms, we've seen plenty of those in the past 5 years, right? Ocean acidification, that's one that you are going to work on in your workshop on Wednesday. Glaciers and snow cover melting and reducing, precipitation cycles are changing, and we've seen an increase in heat waves in certain parts of the globe. So let's look a little bit more at the data on this. And I want you to think about how might this affect biodiversity? Okay, snow cover. So here's the data on snow cover. This is Northern Hemisphere spring snow cover. And for a lot of you in class who are skiers, like myself, I love cross-country skiing. This is not good news, right? So we started taking measurements globally in the 1920s, and you can see it's not a dramatic trend, but there's a definite downward trend in the millions of square kilometers globally covered with snow during different parts of the year. So you can see that now it's gone down quite a bit. So it doesn't bode well for the ski industry, which we'll talk about later. So another impact, warming oceans. So here's some data from different monitoring stations globally looking at global average upper ocean temperature. So that's the top part of the water in the ocean. That's just unmistakably increasing, right? And this is actually contributing to sea ice melt, right? Because the sea ice is sitting in the ocean, in the water. So as that water warms and the climate warms, the sea ice is being reduced, and we can see that clearly over time. So this is a picture of what that looks like actually on the ground. So that yellow line shows the average minimum extent of sea ice from 1979 to 2010. And what you can see there in white is the actual minimum extent last year. So I'll just show you that animation again. So that's the extent that the white is the extent that it was in 2018. So it's definitely reduced, and we know that affects all kinds of species, from the ubiquitous polar bears that are always used to talk about climate change to many other species, Arctic species, and also species who are marine species but feed on those species, right? Like like seals and killer whales. If their prey population is reduced, then their population will be reduced. So all this melting ice is making sea level rise. And that is a pretty clear trend. And we see a lot of that in our own country, right? Not up here in the North Country, but actually we do see a little bit of it, because it's not sea level rise, but we see that we have more water in the Great Lakes each year, and that's increasing the height of the St. Lawrence River and causing a lot of property damage. But globally, sea level rise is affecting coastal areas, and I don't need to explain to you the damage that causes to houses and buildings and beaches worldwide. Okay, so we're almost done, a couple more slides, but I just want to tell you about this one, because this is the one you're going to focus on in your Wednesday workshop. So this is about acidification. Why does climate change cause oceans to become more acidic? Okay, here's why. As you get more carbon dioxide in the air, it's absorbed by the ocean. So we always talk about like the tropical rainforest being a huge carbon sink, right? A place that takes carbon dioxide from the air and stores it. But actually the biggest carbon sink on Earth are the oceans. So carbon dioxide dissolves into water. And so that's what's happening. As there's more carbon dioxide in the air, more dissolves into the water. And if you add carbon dioxide to water, it makes it more acidic. So think about the last time you drank like a fizzy beverage, right? Like a fizzy soda or seltzer, any soda. Those are acidic. You'll know that when you get old and you have to take like heartburn medication after you drink a soda. For real. So that's acidic. It's because it's acid. And so as that carbon dioxide dissolves into the ocean becomes more acidic. So what you see on this graph is the amount of carbon dioxide at the surface of the ocean, that's in blue, it's increasing. And the pH of the ocean, that's in green, and it's decreasing. It's decreasing. So in case you don't remember pH, a pH of 7 is like neutral. A pH of below 7 is getting acidic, and a pH above 7 is basic. So this is more basic than acidic, but that doesn't matter. What matters is that the species that live in the ocean are adapted to that pH. And if it gets much lower, it affects them negatively, right? They're not used to that acidity. So this is something that we're just starting to realize and measure the effects of. Okay, so that's it for that video. So go ahead and, if you want to, you can take the mini assessment 2, the questions that correspond to this, or you can go and watch the other 2 videos and then take the mini assessment at the end. Okay, thank you.